Okay, we have come to the last question in this set of challenging trigonometry questions. And this one is quite hard. So, the first thing I'm going to do is prove for you the hint I gave you at the start. So, the hint I gave was that sine of 3x is equal to 4 sine 60 minus x times sine of x times sine of 60 plus x. And all of these angles are in degrees. All right, so let's prove this first. So I'm going to prove it from the right-hand side because the right-hand side is a little bit more complicated. So the right-hand side equals this expression. And I'm going to write the sine x first. And then sine 60 minus x, sine of 60 plus x. Now we can use the compound angle formulas for sine. So for sine of x, now this first term is going to be sine of 60 times cos of the second term, which is cos of x. And then because it's 60 minus, so we're going to need a minus sign here, and then swap it around. So sine of x cos of 60. And then the second term, well, we're going to do something very similar. So sine of 60 and cos of x. And because it's plus, we can plus. Then sine of the opposite, cos of the opposite. All right. So we can simplify this a little bit. So this is for sine x. And we can, these two last, the last two brackets, we can multiply out. And this is actually a difference of perfect squares. So we'll just get the first term squared. So sine squared 60 times cos squared x. And then we'll get the second term squared and subtracted. So sine squared x cos squared 60. Okay, now what's this? So 4 sine of x still remains. So sine 60 is root 3 on 2, so squared is going to be 3 on 4. And we've still got cos squared x. And then cos squared 60, so cos 60 is a half, so cos squared is going to be a quarter. So we're going to have a quarter sine squared x. Okay. Now, we can see there's a quarter inside the brackets and there's a 4 outside, so they're going to cancel out. We're left with sine of x and 3 cos squared x minus sine squared x. Okay. Let's expand. So we'll be left with 3 sine x cos squared x. And this one will be sine cubed x. All right. And we can use the Pythagorean identity here to convert this cos squared x into a 1 minus sine squared x, like so. And then sine cubed x is still there. Okay. And expanding, we're going to get 3 sine x, and then we're going to get a minus 3 sine cubed x, and then another sine cubed x. That's going to be minus 4 sine cubed x. And for those of you who've studied a little bit of trig, you might recognize this. It's actually, we can simplify this to sine of 3x. This is one of its expansions. Okay, so that's proved the identity, which we're going to use quite a few times in part H to solve this question. Right, so let's get to the big deal. So we're trying to solve we're trying to evaluate the product of all of the degrees this time. And we're going to use this fact. So let's call this just our expression. Okay, so in order to use this, we need to think about, okay, what is this actually telling us? We've got 60 minus x and 60 plus x. So if we group the terms in our product cleverly, we can actually use this formula many times. So here's what I'm going to do. I'm going to say, let's imagine x was 1. Then what would happen? Well, the first term we would get is a sine of 59, because 60 minus 1 is 59. And then we've got sine of 1 and sine of 60 plus 1, which is 61. Okay, so that's nice. And what would be the next term? So that's when x is 2. Okay, so x is 2, then we get sine of 58. And then we'd get sine of 2 degrees. And then we'd get sine of 62. And you can see we're actually knocking off all of those signs, which is really useful. And so what would happen? We keep going, right? And we'd get to sine when x is 29, right? So when x is 29, we'd get sine of 60 minus 29, which is 31, sine of 29, that's our x, and then sine of 60 plus 29, which is 89. And so we've actually covered a lot of the terms in our product. What have we missed? We've missed sine of 30. We've missed sine of 60. And we've also missed sine of 90. But sine of 90 is 1, so we don't have to worry about that. Times 1 doesn't change anything. Okay, great. So by grouping it like this, we can use our expression now, because you can see we can just write this grouping as sine of 3 times the middle angle. Sine of 3 times the middle angle. So here, this whole thing just simplifies to sine of 3 degrees. Or in fact, actually simplifies to a quarter sine of 3 degrees, which is quite nice. And then the second group would simplify to a quarter sine of 6 degrees. And this would carry on. And we'd be left on our last term with a quarter sine of 3 times 29, which is 87. And then we're still left with our sine of 30 and our sine of 60. Okay, now I'm going to take out, so within the dot 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 there is also a quarter sine 30 and also a quarter sine 60. So let's take those out. Okay, so we'll have sine of 3, sine of 6, okay, and here, but here within the dot 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 we're going to exclude the sine of 30 and sine of 60. So maybe I just put a star here, and the star means exclude a quarter sine of 30 and a quarter sine of 60. So we're just going to exclude those from the dot dot dot, and then we're going to group them at the end. Right, so that means, okay, the last term is still there. So all of the terms, the remaining terms are still there. But now, because we've excluded it, we have to include it at the end. So we've got a quarter sine squared 30. And we've also got a quarter sine squared of 60. Okay, great. So how many quarters do I actually have? I've got 3, 6, 9, all the way up to 87. So I've got, and 87 was 3 times 29. So I've actually got a quarter 29 times. So 4 to the negative 29. So negative quarter, and then we get to 29 times. Okay. And now this time, we're going to group the terms in a very similar way that we did previously. So we're going to consider x is now 3. Okay, so x is 3. Then that means we've got 60 minus 3, which is sine of 57. Sine of x, so sine of 3. That's the first term. And then sine of 63. All right, nice. And then we have the next one when x is 6. So that'll be sine of 54, sine of 6, and sine of 66. And again, you can see we're rallying it off all of the other terms again in a very similar fashion. But this time only the multiples of 3. Okay, so where would this end up? This would end up with sine when x is 27, right? Because we're going up in 3s, so x is 27. Then 60 minus 27 is 33. And then we have sine of 27. And then 60 plus 27 is 87. And again, you can see we've included all of the terms we want. And then we're left with the sine squared of 30 and also the sine squared of 60. Those haven't changed. They're still there. Okay, great. So now we can use the same trick and just say, okay, well, our x now just becomes 3x and we get rid of the other terms. So this becomes 4 to the negative 29, that's still there. And now this first chunk becomes a quarter sine of the middle one times 3, so a sine of 9. And then we have a quarter sine of 3 times 6 is 18. And hopefully you can see the pattern again. We're going to be left with a quarter sine of 27 times 3, so 81. And so now we've actually got all the multiples of 9. Okay, and we still have our sine squared 30, and we still have our sine squared 60. Great, we're making good progress here. Now all of these have a quarters again. How many quarters do we have? Well, 9, 18, all the way up to 81. That's 9 quarters. So we have another 9. So 29 plus 9 is 38. Get rid of all of the quarters now. And this time around, I'm going to group it like so. Sine 9 and sine 81. I'm going to take the last term again. And you can see we're probably going to use the double angle formula for sine again. So we have sine of 18. And that'll be matched with sine of 72, right? And we'll have sine of 27 matching with sine of 63. I'll write it out this time because there's not many left. Sine of 36 multiplied with sine of 54. And we realize, okay, well, there's a middle term that's not multiplied, right? So what is that middle term? It's sine of 45, right? And we've also got the sine squared of 30 and still the sine squared of 60. So it's good that we've got the sine of 45 because we know what the value is. It's root 2 on 2, so that's fantastic. Okay, great. So what's happening here? Well, because I've got sine of 9 and sine of 81, we're going to use the same trick as before. And sine of 81 is cos of 9. And so this is just double angle formula for sine. And so I'll still keep the 4 to the negative 38 here. But this time we have a half sine of double the angle, which is 18. And we have a half sine of double the angle, 36. And we have a half sine double the angle, 54. And a half sine double the angle, 72. Right? And we've also got our, I think I'll expand it out this time, right? So sine of 45 is root 2 on 2, and we've got our sine of 30. So sine 30 is a half, so sine squared 30 is going to be a quarter. And then sine 60 is root 3 on 2, so squared is 3/4. Okay, so where are we now? We've got a lot of quarters and a 4 to the negative 38. So let's try to clean this up a little bit. So let's see. We've got a 3. We can't do anything about that 3. Now we've got this 2 to the negative 76. And All right, so let's just take all of the halves away. So sine 36, sine 54, and sine 72. And how many did we just take away? So we took away 4 halves. We've got another half in the root 2, that makes 5. And then another 2 from the quarter, another 2 from the quarter. So that brings up to, that should be 2 to the power of negative 9. And we'll still have our root 2. Okay. Let's combine the 2's again. So we've got 3 times 2, and so 76 plus 9 is 85, negative 85. And we're going to use the trig again. So sine of 18, let's group that with sine of 72, because those two add up to 90. So they're complementary. And what about these guys? They're also complementary, right? So I'm going to put times in the middle so that we can differentiate. Sine of 36 times sine of 54. Aha! Those also add up to 90. And we still have our root 2. Don't forget that. Great. So what's going on here? So this is 3 times 2 to the negative 85. And we've got sine of 18, cos of 18 by complementary angles. So double angle formula, a half sine of 36. And what about this one? This is a half sine of 72. And we still have our root 2. Okay, so we've gotten to very far now. And this is why your teachers at school never told you to write exact formulas for trigonometry, because it takes forever. Okay, so now we need to know what sine of 72 is. So we know what sine, so we know what cos of 36 was from part A. So this is going full circle now. We want to know cos of 72 first. So this will be 1 minus 2 cos squared of 36. This is one of the trigonometric identities for cosine. And then 1 minus 2, and in part A, we worked out what cos of 36 was. It was 1 plus root 5 on 4. And now we're going to square that. Okay, so now we have 1 minus. Okay, so 2 times 1 on 16 is 1 on 8. And we'll have 1 plus 5 plus 2 times 2 terms multiplied together, 2 root 5. Okay, so this is 1 minus 1 on 8. What's this? 6 plus 2 root 5, right? So 1 minus a quarter, 3 plus root 5. And we'll probably simplify that even further. So 1 minus 3 quarters is a quarter. And we're going to subtract root 5. Righty, so now we want sine of 72. So sine of 72, and we're going to use the same trick. 1 minus cosine squared of 72 degrees. This is Pythagorean identity, and we know it's going to be positive because 72 degrees is in the first quadrant, so sine has to be positive. All right, so this will be 1 minus this value we just worked out squared. So a quarter squared is a 16th, and then we'll have our 1 minus root 5 squared. Okay, and so we have 1 minus 1 on 16 minus 5 on 16, and 2 negatives make a positive, so we have plus, and then 2 times the 2 terms multiplied together, 2 root 5 on 16. Extend that bit. Okay, so 16 minus 1 minus 5, so 16 minus 6 is 10. So this is equal to 10 over 16 plus 2 root 5 over 16. And so we can say that this is equal to 10 plus 2 root 5, square root all of that, over 4. Okay, now we have all of the ingredients to write this in exact form. So let's come back up here. Just a reminder, this is the thing we want. So let's copy that back down here. Rightio. So this is our expression. Our expression is equal to this guy. And now we can plug everything in. So 3 times 2 to the negative 85. And now we've got the half and the sine of 36. Now from part A, we know that's equal to 10 minus 2 root 5 all over 4. So actually the format's very similar. And we're going to see that's going to become quite convenient. So half. And we've got what we just worked out, sine of 72. So 10 plus 2 root 5 on 4. And chuck on that root 2. Don't forget that root 2. Okay. So, we've got 3 times 2 to the negative 85. Now, we've got a half and a quarter and another half, another quarter. So that's 1 over 2 to the power of 6. And now we've just got the square roots. So 10 minus 2 root 5. And then 10 plus 2 root 5. And then we've also got the root 2. Okay, but when you multiply thirds, you can just multiply the insides. And now the insides is a difference of perfect squares. So we just need to square the first term, subtract the square of the second term. Okay. So first of all, 3 times 2 to the power of, so 85 plus 6 is 91. And now we're going to take the square root of 10 squared, 100, minus, so this 2 root 5 squared. So what's that? That's 4 times 5 is 20. So minus 20. And then we also have another root 2. And we can smell the vectory here. So 2 to the negative 29, 10 to 21. And this is root 80 times root 2. Yep, but this is 3 times 2 to the negative 91. And this is 4 root 5. And this is root 2. And so finally, we can write this as 3 times 2 to the negative, so the 4 is 2 to the power of 2, so negative 89 times root 10. And so our final answer we can write very neatly as 3 root 10 all over 2 to the power of 89. Whew, so that's how you write the product of all of the degrees from 1 up to 90 as an exact value. And yeah, this took me a whole morning to work out. So yeah, let me know if you find any easier ways to approach this. And yeah, that concludes the series. Thank you for watching.